After my conversation with VJ, it was clear to me that for at least the next 20 or 30 years, we can't stop burning coal if we think about it at a global perspective. So then the question is, can we burn coal more safely in terms of public health hazards and near-term environmental damage? And for fossil fuels in general, and coal in particular, what can we do to reduce the overall carbon impact? To find the answer to these questions and others regarding, well, basically burning stuff to produce energy, I reached out to Professor Richard Axelbaum, who, not so coincidentally, is also in the Energy, Environmental, and Chemical Engineering Department here at WashU. Rich holds the Stifel and Quinet Jens Professor of Environmental Engineering Science Chair. And if you think that's easy to read, you're mistaken. So, Rich, welcome.
Thank you.
Can you just say a little bit about your research in general, sort of over the long term, and specifics more recently?
Sure. I've been involved in energy research for 27 years at Washington University and have been involved in a wide range of areas of energy, many of them being related to fossil fuels. But actually, more recently, in the late 2008, began focusing a major part of my effort on addressing coal and how we can utilize coal in an environmentally sustainable way.
As I think you know, your colleague Vijay Ramani says we're going to be burning fossil fuels, including coal, in the world for quite a while. So I guess the first question is, do you agree?
I do. Coal has the characteristics that, number one, it's pretty ubiquitous around the world. The major centers that require large amounts of energy, China, India, Germany, South Africa, the United States, have abundant coal reserves. That in itself is not a reason to utilize them, but it certainly is a benefit of having coal in that there's, from a global perspective, the major challenge of energy is that we need it. It's our lifeblood, and we need to have sustainable quantities of it and reliable quantities of it, and having it distributed throughout the world is a means of ensuring that the world has access to coal. The world does not have wind resources worldwide, doesn't have solar resources worldwide, doesn't have oil, gas, or even nuclear resources that are available worldwide. So there is a uniqueness about coal in terms of being available. When it comes to actually storing coal, it also has a unique feature in that if I want to have a source of energy that is not at risk, I can take a field and pile coal on it, and that field can last me 6 months. And I know that it's going to be there for me. There's not another single source of energy in the world that can make that statement. So when we're talking about security, our national security, to know we have a resource that we can just dump on the ground and it's there to pick it up when we want it, is of enormous value.
So in some sense, it was able to drive this explosive growth in the consumption of energy because, frankly, the energy was just there. Is that a fair characterization?
That's great. It was there when we wanted it and where we wanted it.
There are lots of fossil fuels. There is a petroleum-based, natural gas, even wood. Why is coal always singled out as like the evil, worst possible fossil fuel?
I've pondered this myself quite a bit, and I can certainly give you my opinion. Number one, I think historically, coal was not regulated until the 70s. So we have pictures and memories of polluted cities. We have pictures of China, Beijing, and seeing polluted cities. And since we remember the pictures of polluted cities being due to coal, then we project that those polluted cities must be due to coal. In China right now, the new power plants are as clean as a natural gas burning power plant in terms of criteria pollutants, the local emissions. Nonetheless, we consider the pollution in China being due to coal power plants. In fact, when coal is involved in pollution, it's due to coal for cooking stoves and for heating, and not for power plants. So we have the ability to have clean skies with coal-burning power plants. We have that in St. Louis with 80% of our energy from coal and very clean skies. So intrinsically, coal doesn't have to have smoke coming out of the stacks, but we associate it with that. It's also, it looks dirty. It gets on your hands. A coal miner has the black under his, on his cheeks. So we have this vision that coal is dirty from our memories, and it's hard to shake that.
So there's this question of essentially the particulate that coal produces and some of the chemicals that go right into the atmosphere that have immediate health effects. And having been to China multiple times in the last couple of years, there are times when, because of coal burning plants generating heat, that the atmosphere is very difficult to breathe in. Is it economically plausible to just upgrade that so that they don't have that problem?
It is, and they are. In other words, what they are doing right now is they are taking their older plants, their less efficient polluting plants, and replacing them with highly efficient non-polluting plants.
As you know, the term clean coal is controversial. And my sense is that it's controversial because you can talk about clean coal when you're talking about those particulates and those chemicals, but not about the carbon and the carbon dioxide. So where are we in the ability to have less carbon dioxide emitted from fossil fuel plants, both LNG, which produces, I presume, a reasonable amount of carbon dioxide as well. Where are we on our ability to do this effectively and not produce as much carbon dioxide into the atmosphere?
Well, we've had a number of demonstration sites. We have 2 ongoing sites right now, one in Canada, the Boundary Dam facility, also one in Texas, the Petronova facility, that have demonstrated that we can capture CO2 from power plants and use it for enhanced oil recovery to be able to sequester it underground so it remains out of the atmosphere. So that technology has been demonstrated effectively. Now the challenge is to be able to do that better and do it at a larger scale. Right now, it's limited to specific applications, which is what you would want to have starting off with a technology. Identify the most promising use of that technology and apply it in that case. But to really be effective at reducing the CO2 emissions, it has to be at much broader scale.
I know some folks are skeptical that the time frame is that we could get to that scale sooner than we could get to some other solution that provides energy by not burning things. What is the time frame by which you think it becomes economically viable to be able to burn fuels in a way that the carbon is not as problematic as it is now? And presumably, the politically viable is deeply, deeply tied to economically viable.
In terms of being able to expand the scale of these units, that is doable today. The challenge is really economics right now. We're at the beginning of these technologies, and just like the beginning of solar and wind, the cost of those technologies was very expensive. If we looked at those costs today, we would say, well, there's no way we're going to do that. So if you look at the costs of carbon capture today, and we say we're not going to do that, then we're stuck. But if we realize that if we have large-scale implementation of this, then of course the experience that we've gained from that, the economies of scale, will bring the price down. And of course, it's even needs to be brought down more than that, because right now we're talking about what we know in terms of technologies and just expanding the application of those. What we really want to be able to do is come up with radically improved technologies that actually bring that cost down.
So let's talk a little bit. This is supposed to be an engineering show. What is the mechanism, the method, generally the approach taken now, and what methods are being explored that you think might yield the most likely advances that would push this forward to the level that it has to get?
What you'd expect, the first generation technologies were saying we have a power plant. That power plant's emitting CO2. We have to stop that emission from leaving. So the approach to that is to have a chemical that can grab the CO2 out of the exhaust, capture it, and then take it off that chemical, and now you have a concentrated stream of CO2 that you can use for enhanced oil recovery or for sequestration. And that would be considered what I call a patch. Now, if you think about it, power plants have continuously patched. So they started off just producing power, and particulates, NOx and SOx, all the pollutants just came out of the stack. People were happy to have the power, not as worried about the environment. As our technology, our economies improved, we got more concerned about health effects, and so then we put a patch on the system to get rid of particulates, then a patch to get rid of the SOx.
SOx being?
Sulfur dioxide, sulfur-based, acid rain.
I was going to say, I grew up in New York, and I remember that the acid rain was a big deal, and then eventually acid rain went away because they did something in the Midwest that made us all very happy.
That's right. They had new technologies, and they switched fuels, and that combination really eliminated the issue in terms of acid rain. So now we actually have another patch. Now we have to remove the CO2 on the back end. But as you take a basic technology and just keep patching onto it, you end up just increasing the costs, and there's no intrinsic benefit to that. So what needs to happen now is there has to be an approach that recognizes our goal is not just to produce electricity. Our goal is to produce electricity and have zero emissions, meaning we have to do something with the CO2. And the most promising approach is in utilizing it, for example, for enhanced oil recovery or sequestering it. So then the question is, how do you take coal and make electricity, but also be able to produce a stream of CO2 that you can sequester? And not from a patch, but from a redesign of the concept.
So a redesign of how we burn coal.
That's right.
So for the naive, you stick coal in something that can hold the heat, you light it, you capture the gas, then the gas goes through some things that remove some of the particles that you don't want, some of the chemicals that you don't want, but you didn't fundamentally change the burning. You're talking about changing the actual way it's burned.
That's right. Yeah, in other words, when we started, we wanted to just produce electricity. Now, if you think about it, we have two products. One product is electricity. The other product is a stream of CO2 that we can either sell or dispose of. So then you think about the problem from that perspective, and things change. For example, what we do when we sell CO2 for enhanced oil recovery or sequester it is we have to pressurize it. So the existing approach, for example, the Petronova plant, is that they will capture the CO2 and then they put it in a compressor and compress it down to about 100 atmospheres. It's quite high pressure. And then they can stick it underground. However, what happens is once you actually know you have to pressurize anyway, you can now pressurize the power plant. So existing power plants don't operate under pressure. Your car operates under pressure. The plane, it operates under pressure. Existing power plants don't operate under pressure, and that's just inherited from the past. But now if we can operate the power plants under pressure, since we need to have pressure anyway, it doesn't cost us anything extra to have that pressure. In the past, it would have. That's why we don't do it. But now when you have to have pressurized products, then you can do that at no additional cost. And then all of a sudden, many benefits occur that allow you to redesign the power plant that can actually capture the CO2, produce electricity at an efficiency comparable to what a plant would do when it was really just producing electricity.
I only recently learned that we actually have, I guess we have these domes that capture CO2 that's coming up from the earth, and they enter in these pipelines, and we pipe the CO2 around in order to then use it for various types of oil exploration and oil extraction. So I guess what you're talking about is that you could now capture the CO2 stream, and instead of having these domes and pipelines, et cetera, which I didn't know we had for CO2, you would be able to produce that directly. So there's now an intrinsic value of the CO2 itself.
Exactly right. Yeah, they're actually paying for that CO2 right now. So they could pay the power plant for that CO2.
So is this going to happen?
I believe so. My crystal ball is this challenge associated with the intermittency of wind and solar is going to become very evident to society. Right now, we're somehow believing problem's going to go away, but it will not go away. Reliability is the fundamental point, and if we don't address reliability, then we're going to miss it. And so ultimately, you have to match supply and demand. It will become impossible for us to really be able to do that with intermittent sources. And so once that reality occurs, it's occurred in Germany, it will occur in the United States. And at that point, we have to have technologies available. And they have to be reliable technologies that are low-carbon solutions. So we see it as we don't know when. We do know it will occur, and we need to have those solutions available when it does.
Rich, thanks so much for coming in and sharing with us. It's one of these topics that is tremendously politically charged. I think from an engineering perspective, our goal is to make sure the world has as many options as possible, and then we leave it to the folks who control economy and political world to make those decisions. But our goal is to give them all the levers that we can. So thanks for the work you do, and thanks for coming in.
Thank you very much, Aaron.